Video number 230, adding and subtracting fractions. In one of the previous videos, we worked on this problem 2/3 plus 1/4. We divided the thirds into 4 pieces, divided the fourths into 3 pieces. Thus, we ended up changing the denominations to twelfths. And here's how that officially works out. You'll multiply both the top and bottom by a 4 because that's a value of 1, which does not change the value of 2/3, just changes the way the 2/3 looks, 8 out of 12. Same way with the 1/4, you end up with 11 twelfths, and we can then add together 2 different denominations. Now here's a few examples of if the denominators are already the same. We already have common denominators. We have 5/10 plus 3/10, and so on. So here's 3 different examples that you might see. The first one, we just simply get 8/10, which reduces to 4/5, okay, or simplifies. In the second example, the numerator ends up being 10 and the denominator is 10. So sometimes the 2 fractions will add together to give you the whole number of 1. So you'll go ahead and reduce that down to a 1. And then also, the third example, you'll end up adding the numerators together. Again, 7/10 plus 4/10 is 11/10. It doesn't change. You don't do 7 footballs plus 4 footballs and then magically get 11 basketballs. So in other words, what I'm trying to say is you don't put 20 here, okay? You're adding together the number of tenths, okay? That's how we're doing this. Therefore, you get 1 and 1/10. Now, what if we were to subtract 2 fractions? Same thing. We're just going to subtract. We have the same denominators. We just go through and subtract. 5 minus 3 is 2, so therefore 2/10, and we end up with 1/5. And then, of course, sometimes you'll just subtract the 2 numbers and you won't have to reduce the fraction. 7/10 minus 4/10 is 3/10. You're all set. Now, what if you have mixed numbers? We have 4 and 5/8 plus 8 and 1/8. Well, what we could do is, obviously, the answer is going to be more than 12 because we have 4 plus 8, basically. So there's a couple ways to do this problem, but the easiest thing to do is to go ahead and separate this into 4 plus 8, which is 12. So we end up with 12 plus 5/8 plus 1/8. Okay? Then we have 12 and 6/8, which gives us 12 and 3/4. So you just go ahead and add the whole numbers, then add the fractions, then add all that together, because 12 and 6/8 means 12 plus 6/8. Okay, so therefore 12 and 3/4 means 12 plus 3/4. So that's how the mixed number will work. In the second example, what ends up happening is after you separate the fractions, now you do the 7 plus 3, there's 10, okay, so you're all set. 10's the whole number. Then 7/10 plus 9/10 turns out to be 16/10, which is definitely more than 1. So we end up changing the 16/10 to 1 and 6/10 temporarily. Now that's actually 1 and 3/5, right? 16/10 is 1 and 3/5. So you take that 1 and 3/5, add it to 11, you get, add it to 10 to get 11 and 3/5. Next one, what if we were to subtract, okay? What we could do is this. Now, one of the things we can hopefully understand is that we have to take away 8, and then we have to take away the 1/8, okay? So 11 and 5/8 is some kind of numerical value. We're going to take away 8 from it, and we're taking away the 1/8. All right? So what we do is we do 11 minus 8, which is 3. Okay? So we do 11 minus 8 plus whatever 5/8 minus 1/8 is. So what we're going to do is we're going to subtract 8 from 11, then we're going to subtract 1/8 from 5/8. This is just rearranging the way we go ahead and do this problem. So the subtraction occurs within each of the separated parts. So you subtract the whole numbers, subtract the fractions, put it together, you're all set. All right? So 5/8 minus 1/8 is definitely 4/8. So therefore, when we subtract these 2 mixed numbers, we get 3.5. All right? Now, in the second example, we had 11 and 7/10 minus 3 and 9/10. What's goofy about this problem is when you do subtract 11 minus 3, you get 8. And then now we need to perform this subtraction, 7/10 minus 9/10, upon subtracting the fraction portion of the mixed numbers. But you see, this turns out to be a negative number. So what we do is we kind of quote unquote borrow from the 8, like we would if we were doing the basic subtraction from chapter 1, okay? So what we do is we add another 10/10 to this 7 over 10, all right? We add a 1 here, a whole 1. Taking the 8 down to a 7 makes the 7/10 become 17/10, okay? Then we can subtract here without having to worry about negative numbers. So therefore, 17 minus 9 is 8, so we get 7 8/10, which gives us 7 4/5. All right? So that's a pretty interesting problem, and this is precisely how it's done. Here we go. Here's a situation where actually, we can actually do this problem in 2 ways. The first method would be like we've done here in the past, where we go ahead and separate, and we have 3 plus the 2 is 5, and then we're going to go ahead and add together the 3/5 and 1/8. Now here, what's different is that we actually have to get common denominators. In the previous mixed numbers that we just did here in this video, we already had the common denominators. This time, we separate, then we got 3/5 plus an 1/8. We just get the common denominator of 40 and we move forward in our life. We're okay. 5 and 29/40. Now, another method. Now, I like this method the best. If you can do this method, please do. Here's another method, though, that does work. The only problem with this is that people think that this second method is the only method. This is not the only way to add 2 mixed numbers. You can just add the whole numbers, then add the fractions, and you're all done. So the second method here seems to be the one that students are only familiar with, which is a problem. So there are several methods to solve problems, and knowing the various methods is definitely a quality skill to have, knowing the different methods. So 3 plus the 2, we're not going to do it that way. We're going to change this to an improper fraction. Improper fraction. Now you can see how this second method starts to lose some of its power, because do you really want to get common denominators here when you have to work with 18 and 17? This is actually a rather difficult thing to do if you want to do mental math. You have to multiply the top and bottom by an 8 to get 144, top and bottom by a 5 to get 85. Then you got to add that together, 229. Then you got to convert this to a mixed number. Do you see how this first method is actually probably easier the majority of the time? This might be easier only when you have small denominators to work with, because then you'll have an easier time getting common denominators. So there's a couple methods there. Now here we're going to end this video with a couple very, very basic addition and subtraction problem. If you have 8 plus 2 and 1/8, okay? Well, obviously the answer is definitely more than 10. Well, by how much? Well, by 1/8. So the answer is just simply 10 and 1/8. Okay, 10 and 1/8. Now here you're going to have 8 minus 2 and 1/8. Okay, look, what if we were to subtract? Well, if you take 2 from 8, you're down to 6. Okay? But if you take away something that's more than 2 from 8, you'll be down into the 5s, right? Because 8 minus 3 is 5. So therefore 8 minus 2 and 1/8 is somewhere between 5 and 6. So how far do we dip? Only 1/8 into the 5s. And then from 6, 1/8 from 6 is definitely 5 7/8. So that would be a very good mental math skill to have. Let's just do one more real quick. What if you have 7 minus 2 and 3/8? Okay, so 7 minus 2 and 3/8. Well, the 2 would take you down to 5. So then the 3/8 is going to have you dip into the what? The 4s. By how much? By 3/8. So 4, and if you dip down from 5, you'll land on 5/8, because you're only going to go down 3/8. So you're at 8/8, then you go 7, 6, and then 5. All right? So there you have it, adding and subtracting fractions.